Welcome to the final episode of the Python Basics series. In this video, we'll go over how to create reusable code that we can run at any point by making use of functions. So firstly, let's go over why we even need functions in the first place. So up until now, our programs have just been a long list of instructions that we had to follow every single time we ran the program. However, a function lets us store part of those instructions, and then whenever we call the function, we can perform those instructions. So we can do them repeatedly in a more convenient way. For a real world analogy, it's like a recipe where instead of having to do each step, instead of having to do each step individually and focus on those individual steps, we can just find the recipe in our cookbook and then just follow the instructions there. It's a much more convenient way of programming, and it helps us make our code cleaner, shorter, and it makes debugging a lot easier because all the instructions are in one place. So now let's learn how to actually implement functions and use them in Python. So in order to define a function, we can make use of the def or def keyword, and then a space, and then the name of the function. For function names, you can just use the same convention as variable names, which is just snake case, lowercase words separated by underscores, and then a colon. Actually, before the colon, there are actually a pair of parentheses, and then after the colon, there's an indented block of code. So it's similar to an if statement or a for loop, except this is for a function this time, but it has the same indented block, and inside that indented block is the code to run, or the instructions that the function has. And once we've defined our function, we can call it by just writing out the function name and then making use of that same pair of parentheses at the end to actually call the function instead of just refer to it. So to practice this, let's actually try defining a function ourselves, which will greet a user. So we can use the def or def keyword here and then a space, and then the name of the function can be greet user because that's what we're doing, and then a pair of parentheses, and then a colon after those parentheses, and then enter. You can see it creates an indented block of code here, and then inside of here we'll just print the greeting. So we can print hello, how are you doing today? And then we can print another line too, maybe saying excited to start coding. And then after we're done writing all the code in the function, we can just press enter and hit backspace. That will remove the indentation so we can go back to the main code. And now we have to call this function so that it runs all these print statements. So we can do that by typing in greet underscore user and then typing in the parentheses again. This is to make sure it doesn't just refer to the function greet user, but actually calls it so that it actually runs these print statements. So if we were to run the code, you can see that it prints out the two messages that we put inside the print statements. It's good that we can use functions to just create procedures like this, but they're not really that useful on their own. In order to make them more useful, we can make use of defining the function with parameters. So parameters are just placeholders which we have to fill in order to make the function work. And the way that we fill those placeholders in is by making use of arguments, which we put inside the function call inside the parentheses. So in order to define a function with parameters, we can make use of similar syntax as before, except inside the parentheses, we can put the names of the parameters separated by commas. And then when calling the function, we can pass in values for those parameters, which are represented by arg1, arg2, and so on in this code example here. But we can pass in arguments by separating them with commas and putting them in parentheses, just like the function definition. So let's say in this greet user method, I wanted to greet the user by name. So in order to do that, I can get the name by adding a name parameter into this function. And then I can print it out here in this hello sentence. And so the way I can embed the name is by making use of an F string, which is by typing in F in front of the string. And then I can use that, and then I can use curly braces to then put the name inside of this bigger string here. Embed the name in this hello, how are you doing today string. And then we can pass in a name to the function call now, because that's what the greet user function requires now. And so then we can use the name Sandy, for example. And if I were to run the Python code, you can see it says, hello Sandy, how are you doing today? Excited to start coding. And we can add another parameter too, this time maybe for the activity that whoever's being greeted is doing, so that the greeting's more relevant to them. And so we can create another parameter for activity, and then we can use another F string here, and then we can embed activity in this excited to start string here. And then for the activity, for this example, we can just say studying. And then if we run the code now, you can see it asks Sandy if he's excited to start studying. And then we can change the activity if we want. For example, we can say maybe writing the essay instead. And then it'll ask excited to start writing the essay. And then we can change Sandy to Mark here if we want to greet a different person. And then it'll change the greeting at the top here. Now that we know how to provide a function with input, let's look at how it can produce output now. So we can make use of return values to do that. And so to define a function with a return value, at the end of the indented block of code, we can say return and then a value to output or send back to the caller of the function. So we always want to put return at the end of the function, because once a return statement is executed, the function will be exited, meaning no other code in the function will be run. So to illustrate this more clearly, I've created a new function which is meant to approximate a logarithm. So in order to do this, I created two variables, one to represent the exponent, which is what we want to return, and then a number just for comparing with the value that we give. And then we loop through while the number that we're repeatedly checking is less than the value we provide. And then if so, we keep adding 1 to the exponent and then multiplying the number by the base until the number exceeds the value. And then from there, we can just return the exponent because for logarithms, you're solving for the exponent, so that's what we want to return. So in order to do that, we can enter and then exit out the while loop through a backspace. And then we can type return exponent. And then in order to test this logarithm approximation function, we can pass in some example values. So for example, 2 to the power of 32 and then 32. And then if we run the Python code, you can see it doesn't print out anything. And so this shows a common misconception. So returning a value doesn't actually print it out or do anything in the console. It just returns it back. And so the value, the exponent that's returned, basically just replaces this function call here inside the code. So log base 2 of 32 is actually 5. So it would basically just look like this. So it's just a meaningless 5 because we're not doing anything with it. However, we can print it out and actually see that it does return 5. And then we can even do different numbers like 4 or 64. And then you can see it prints out the appropriate number. So right now in our examples, we've only really been using one function at a time. However, in bigger programs, a lot more functions are used, like at least 5 to 10. So that way we can just repeatedly call them whenever we need them. And if we want to edit the function or modify it in any way, all the instructions are in one place, so we don't have to go looking around the code to find every instance of those same instructions if we weren't using functions. Next, let's go over another common misconception. So you can see that we've defined a lot of variables inside the function here, like exponent and test num. However, when we try to actually access them outside of the function, you can see we get an error saying these variables are not defined. This is because they're defined in the function and only in the function. They're not defined in any other parts of the code, like this outer part of the code right here. So variables that are created within functions can't be accessed outside the function. This is called local scope, and it's a common term you'll see if you go into more advanced Python. For the final challenge of the Python Basic series, since we're going to be moving on to how to use AI to code Python next, let's do an AI related challenge. So your task is to create a function that helps with formulating AI prompts. And you want to get two parameters from the user, topic and tone. And this function should return a sentence saying, write a whatever the tone is, essay about, and whatever the topic is. So it should return the sentence as a string. It shouldn't print it out inside the function because that's what you want to do outside of the function when you call it. So after this challenge, that's it. We're done with Python basics. So just to recap, we now know how to store data using variables and data types, which was the second video, making choices through if-else statements and conditionals, which is from the third video, organizing data through collections like lists and dictionaries from the fourth video. The fifth video went over repeating tasks with loops. And finally, in this one, we learned how to bundle code for later use by defining functions and calling them. So now that we know the basic grammar of Python and how programs are structured, in the next series, we'll be going over how to code with Python by using AI to streamline the coding process. Thank you very much for watching. Like and subscribe if you enjoyed the video, and make sure to look out for the Python with AI series coming soon.